How's everybody doing? Good? All right. So warm-up is on the screen. Warm-up number 58, and it reads, number 1, make an input-output table for f of x equals 1 over x and plot the points. Number 2, graph f of x equals x, then transform using g of x equals f of x minus 4, close parentheses, minus 3. Number 3, factor. Part A reads 2x cubed plus 4x squared minus 3x minus 6. Part B reads 2x squared plus 5x plus 2. Number 4, divide the polynomials by synthetic division with synthetic division. 4x cubed plus 3x squared minus 3x plus 14 divided by x plus 2. And number 5, solve the quadratic equation y equals 2x squared minus 4x minus 30. And that should be our warm-up for today. I'll give you time for copying and working on that. You should be able to do all of them minus number 1. If you want to skip number 1, that's fine. But I mean, I think it's doable. And then I'll elaborate on number 1 because that's going to take us on to the next concept that we're going to cover after the concept that we're starting today. All right, guys. All right, so let's get to work, and I'll come right after to go over those. Ready, go. All right, so here we go. Let's go over this warm-up. I'm going to leave number 1 till the end. Let's see. Actually, no, I'm going to start with number 1. Here we go. I think it's fairly simple. I just want to do a quick intro for that. So here we go. It says make an input-output table for f of x equals 1 over x. Does everybody remember how to do an input-output table? Yes, x, f of x. And what values did we use for the domain? Yeah, the ones I always told you, -2, -1, 0, 1, 2. That should be your bread and butter, your cornflakes and milk, your burrito, bean burrito. That should be the go-to every time, okay? So here we go. So if I was to substitute values in here, I would do the first value, which is -2. F of -2 will be 1 over -2. And what is this? This is -1/2. The next one, f of -1, which is 1 over -1, which is -1. Next one, f of 0, which is 1 over 0. Now, look up to the screen really quick. Can we have 0 on the denominator? No. Remember when we covered rationals that I gave you the definition of rationals are the set of all m over n, where m and n are integers and n could not equal to 0. That means the denominator cannot be equal to 0. No, it cannot. That means this is called undefined. For those that were with me since Algebra 1, who remembers the slope of this one, it's undefined because we can't really tell whether it's going up or down. That's why it's undefined. Next, f of 1 equals 1 over 1. What is 1 over 1? 1. And f of 2 is 1 over 2, which is 1/2. So if we plot and graph those, here we go. Kind of crooked. Okay, let's see. Right there. Okay. So I'm going to space this out. So I'm going to go -1 and -2 and -1 and -2 and 1, 2, 1, 2. Okay. So let me plot those. -2, -1, -2, -1. I'm sorry. -2, -1/2, -2. -1 down here, so -1/2 is up. My goodness, what's up with my pen? Sorry, hold on, let me erase this. Okay, let me try this again. All right, -2, -1/2 is right there. There it is. -1, -1, -1, -1. Okay. Undefined, that means at 0, we're not going to plot anything on 0. 1, 1, 1, 1 is right there. And 2 and 1/2, 2, 1/2, which is right there. You're like, Mr. Q, that It looks kind of sporadic and all over the place. Well, actually, it's not, guys. Look up. If I was to graph this, this is how it's going to look. You're like, what? Oh, yes. Students, rational functions, students. This is a soft introduction that I'm doing just so that your noodle can get used to it. When we come back from spring break, we're going to get full on to rationals, which is fractions and functions. Let's go, your favorite. So you're like, okay, this is cute. So anyways, that's how you plot those and graph those. Once again, those are known as what? Rationals. So far we've covered linear, quadratic, cubic. Today we're starting with a new concept, and this is going to be the following concept. Okay, let's move on. Number 2, it says graph f of x equals x, and then transform g of x equals f of x minus 4 minus 3. So let me make some space right above that to graph. So here we go. Let's get a coordinate plane there. All right, so what's our parent function? F of x equals x. That means it's a linear, starts from the point of origin. What is the y-intercept? There is none, that's why it's 0, 0. What is my slope? 1 over 1, so 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, and you graph your line going through those points, and that's our parent function. Hold on, let me move it down a little bit. There it is. All right, so according to the transformation they're giving us, look at this. Which way are we going to move this? Addie, what are we going to do to the transform parent function? We're moving it which direction? Addie?
My brothers are in Zoom, so that you cut it on the last part.
Oh, okay. Then let me get Jaziel. Which way are we moving?
You move it to the right 4 and then down 3.
Right 4 and down 3. Let's go. So our H is 4 and our K is -3, also known as a vertex. So it's 4, -3. What does that mean, Mr. Q? That the point at 0, 0, the point of origin is going to move to 4 to the right, 1, 2, 3, 4, 3 down, 1, 2, 3. So our transform function is going to be somewhere down here. There you go. Yes. And if it was a quadratic, then it would be a parabola moving down here. Or if it was a cubic, same thing, it would move down there. All right, let's go to number 3. It says factor. So group GCF for the first 2 is 2x squared. We're left with x plus 2. GCF for the second 2 is -3. We're left with x plus 2. So my factors, same here and here, are x plus 2. And what's left over? 2x squared minus 3. That was for 3a. Let's go to the next one. Is there a GCF? No. So that means I can factor this using powers. 2 times 2, that's +4. It goes above, 5 below. Factors of 4 that add up to 5. Well, it's 1 times 4. 1 times 4 is 4. 1 plus 4 is 5. We rewrite this trinomial. So we got 2x squared. And instead of 5x, we write 1x plus 4x plus 2. Bring down the last term, and we group. First 2, last 2. GCF is x. We're left with 2x plus 1. GCF here is 2. We're left with 2x plus 1. So my factors are 2x plus 1 and x plus 2. So far, so good? Yes? Yes, Mr. Q. Next, the next one, synthetic division. We start with -2 as our divisor, and we have 4, 3, -3, and 14. And we do the process here. We do bring down the 4. -2 times 4, that's -8. Combined, that's -5. -2 times -5, that's 10. Combined, that's 7. -2 times 7, that's -14. And what is our remainder? 0. So what do we have down here? As our quotient, we got 4x squared minus 5x plus 7. All right, and last but not least, number 5 says solve the quadratic equation. Solve the quadratic equation. And it says y equals 2x squared minus 4x minus 30. What is the first thing we do when solving a quadratic? We set it equal to 0. 2x squared minus 4x minus 30. From there, is there a GCF? Yes, 2. And we're left with x squared minus 2x minus 15. And all that equal to 0. From there, can we factor this trinomial? Let's see. Negative 15. Negative 2 on the bottom. Factors of negative 15 that add up to negative 2. Oh, negative 5 and positive 3. Negative 5 times positive 3, negative 15. Negative 5 plus positive 3, that's negative 2. So I can factor this as x and x, that x squared right there. And we have negative 5 for one and positive 3 for the other. Bring down the 2 and all that equal to 0. Next, to solve, what do? Set each factor equal to 0. Yes, so 2 equal to 0, x minus 5 equal to 0, and x plus 3 equal to 0. So if we solve, let's see, is 2 equal to 0? No, we eliminate that. Plus 5, x equals 5. This one, minus 3, x equals negative 3. And those are my solutions, also known as x-intercepts, also known as what? Roots, or also known as zeros. And today we're going to elaborate more on that. So make sure you have those down in your noodle, okay? All right, let's move on. That was our warm-up for today. Our agenda for today, here we go. Our agenda is warm-up number 58. Today we're starting on a new concept, polynomial equations and zeros. Polynomial equations and zeros. And your home plate for tonight, pages 348, 349, evens only. 348, 349, evens only. And just reminder, guys, today on your home plate, you're going to do exactly what we do in today's session. Don't worry about the instructions on the book. I want you to do what I'm asking you to do from class, okay? That's all I want you to do. So once again, warm-up number 58, polynomial equations and zeros, and your home play is pages 348, 349, evens only. Make sure you copy that. Your asynchronous code, NFT 28, NFT 28. NFT 28. Once again, on that session, the asynchronous, you're going to have at least 3 more problems extra than what we do in class. That's for you to do the extra practice once you're submitting your work. Make sure you submit all of that. And over the weekend, I left you guys a home plate of 8 problems, synthetic division. Go to Canvas, turn that in right now. I'll give you guys some time. Also get a Cornell note. And by the way, this is under the new module. Look in your Canvas. There's a new module titled Polynomial Equations. Polynomial Equations. It should be in there. Okay. So once again, reminder, home plate for tonight, 348, 349 evens only. Go ahead and I'll give you some time to turn that in, and we'll get started in a little bit. All right. So now that you turned in your home play and you have your Cornell note ready with your FAIR model, we're not graphing today, so make sure you just have your notes ready. Here we go. Our objective for today, I can identify rational zeros of polynomial equations. I can identify rational zeros of polynomial equations. Now, I'm pretty sure by looking at it, you know that the concept for today is what? Polynomial equations. And also, those 2 terms should start giving you a picture in your mind, because I hammered pretty much polynomial definition in your noodle. Yes, you already have that? Can you picture what a polynomial looks like? Yes. But today's concept is what? Polynomial equations. Can you maybe picture something like that? Yes, you already have it there, so I'm going to clarify it. However, what are we doing today? We're identifying what? Rational zeros. So that's what I'm going to be clarifying in a little bit. But let's get started with polynomial equations. Here we go. What are they? Polynomial equations, definition. They are two variable equations that have monomials or some or difference of monomials. Here goes again. Polynomial equations are two variable equations that have monomials or some or difference of monomials. You're like, man, it's almost the same definition as polynomials. Of course, but now they are what? Equations. Two variable equations. Example, y equals x squared minus 3x plus 2. So look at it. It says two variable equation. Does it have two variables? Yes, x and y. Is it an equation? Yes, it's got an equal sign. And then it says it has monomials or some difference of monomials. Yes, here they are. X squared is a monomial, 3x is a monomial, 2 is a monomial, and there's some and difference. Yes, okay. That's a polynomial equation. Let me go to the next one. Y equals x times x minus 2, parentheses, close parentheses, open parentheses, x plus 3, close parentheses. Is that a polynomial equation? Yes. Is it two variables? Yes, x and y. Is there an equal sign for an equation? Yes. And are there monomials all over the place? Yes. Okay. Now, focus and think. Once we got through the y's, and when I told you guys that we're going to change that, what did we change that to? Yeah, we changed that to function notation, which was f of x. So copy this example. F of x equals 2x cubed plus 4x squared minus 3x minus 6. Is this a polynomial equation? Yes. Is it two variables? Yes, x and y, but instead of y, we wrote what? F of x. Yes. And are there monomials, some of difference on monomials? Yes, all over the place. Okay. Now I'm going to give you another one, very similar, but instead of using notation f of x, I'm going to give you the notation that they give us in your text. The notation they give us in the text, instead of f of x, they use p of x, meaning polynomial function. P of x equals x to the fourth minus 4x cubed minus 7x squared plus 22x plus 24. Is this a polynomial equation? Well, let's check. Is it a two variable? Yeah, x and y, but instead of y, we wrote p of x. And monomial, sum and difference, yes, there they are. So those are examples of polynomial equations. Okay, let me show you what they are not. Which ones are non-examples? Well, let's see. We got x squared, that's not a polynomial equation. 2 is not a polynomial equation. Negative 3x to the fourth plus 2 is not a polynomial equation. And x squared minus 3x plus 2 is not a polynomial equation. As you're writing those, you should be able to tell why those are not polynomial equations. It's very obvious. So think about it. Why are those not polynomial equations? What do you think, Danny? Why are those not polynomial equations?
Because they're not equations.
They're not equations. So what would be our first obvious hashtag?
Equations.
Yes, hashtag equations only, yes. What's another thing that we should have, Alberto, hashtag what?
Hashtag equal to y,
That or
f of x.
Or it should have, look at the definition.
Polynomials.
How about hashtag two variable equations? Yes. And the last one, I'm going to give you the last one, hashtag various terms, because polynomials, remember when I broke down the polynomial, poly meaning many, nomial meaning terms or parts, various terms. All right. So before we move on to today's session is going to involve a theorem. You're like, oh, snap, Mr. Q, I'm having flashbacks to geometry. Oh, yes. Today we're going to cover a theorem. And before I get to the theorem, I just want to clarify two terms. Here are the terms. The first one would be zeros, and the second would be rational. Rational, I already covered at the beginning of the school year, and I'll revisit that right now, but I want to talk about zeros, okay? So what are zeros? So let me go back to the warm-up. Here's a warm-up. Let me scroll up. I solved number 5, and we said that these two answers that we came up with were solutions, x-intercepts, roots, or zeros. Now, why are they called zeros? Let me show you. Look up to the screen. If I was to take the trinomial x squared minus 2x minus 15, where I got these two factors from, and I wrote it here, x squared, oh, not plus, minus minus 2x, you're just paying attention, minus 2x minus 15. And if I substitute instead of x, oh, minus 15, minus 15. If I substitute one of the x's, what do you think I'm going to get at the end?
A number.
A number, that is correct. And that number is 0. That's why they're called zeros. Check this out. So I'm going to substitute 5 to make it easy. 5 there and 5 there. What is 5 squared? That's 25. What's negative 2 times 5? That's negative 10. Bring down the negative 15. Negative 15 and negative 10, that's negative 25. Negative 25 and 25, that's 0. That's why they're called what? Zeros. What does that mean, Mr. Q? That if we were to substitute these to the original one, we get 0. That's why they're known as zeros. Any questions with that? So that's one thing. Also, if I was to graph a parabola, look up please. And let's say that parabola had the x-intercepts of 5, negative 3, 5, and the y-intercept at negative 15. So that parabola is going to look something like this. Okay. The x-intercepts, if I was to ask you for the coordinates, would be what? Negative 3, 0. And this one would be what? 5, 0. That's the other one, why they're called zeros. Once again, are we clear, you guys, to why they're called zeros? Because any of those numbers make the equation 0, or in the graph, it's part of the x-intercepts that have 0, y. Okay? Next, check this out. Zeros are clear. Let's talk about rationals. Definition about rationals, just to take you back to the beginning of the school year, we covered this with real numbers. We said that rationals are any number that can be written as a fraction. Repeat that again. Any number that can be written as a fraction. First one. How about 23, Michael Jordan? That can be written as a fraction because we can write it over 1. Yes? How about negative 2? Yes, Mr. Q, negative 2 over 1. Okay. How about 0.25? What's the fraction form of that? 0.25?
1/4.
1/4, that is correct. Comma. About 0.6 bar. Fraction form is 2/3, and so on and so forth, with negatives and all that. Those are rationals. So any number, basically, that can, or any real number that can be written as a fraction. Those are rationals. Okay. Now that we have that, look up. Today, we're going to talk about the rationals zeros theorem. Let me repeat that again. The rationals zeros theorem. Copy that. Rationals zeros theorem. I'm going to give you the theorem right now, but don't write it down. I'm going to give you what I write is what I want you to write, not what's going to come up on the screen right now. So once again, you're writing down rational zeros theorem. That's your little subtitle. Ready? All right. Stay focused. Here we go. What does the rational zeros theorem say? It says if p of x is a polynomial function with integer coefficients, okay, and if m over n is a 0 of the polynomial p of x, in parentheses, p of m over m equal to 0, then m is a factor of the constant term of the polynomial p of x, and n is a factor of the leading coefficient of the polynomial p of x. They're like, Monsieur, I have no idea what you just said. That's why I told you not to write it. I'm going to elaborate so we understand what it says. Ready? So you wrote rational zeros theorem. What it says is this. Copy this. What it says is that if we have a polynomial function, look up, such as p of x equals x squared plus 5x plus 6. That means I can make a fraction, look up, a fraction of m over n, okay, where m is the constant term of the polynomial and n is the leading coefficient of the polynomial. Okay, so Let me write that here. This is the constant. Yes, because the constant goes on top, m. And what goes underneath? The leading coefficient. Okay, so looking at this polynomial here, what number would I write on top, Hayden? 6, that is correct, because 6 is our constant, the number without a variable. What is our leading coefficient, Mia?
The 1.
1, that is correct. It's an invisible 1. There it is. So now that we have a fraction, this 6 over 1 is 6. Copy that, please. Hurry up, hurry up, hurry up. Is that it, Mr. Q? No, I'm just giving you the head start in regards to what it means. All right, now that you copied that nicely and pretty like mine, my writing, those that are writing with your feet, stop it. Focus, please. All right, here we go. So the rational zeros theorem, pay attention to this part. Write your utensils down now that you copied it, look up to the screen. The rational zeros theorem says, whenever you have a polynomial and you make a fraction where the constant is on top divided by the leading coefficient, you come up with that number. The rational zeros theorem says that the factors of this number could be one of the zeros of this equation. Do we know what a 0 is? Yes, that if we substitute it in there, it makes the equation 0. You guys remember that? Yes? So what are the factors of 6? Let's see, factors of 6 are 1 times 6, 2 times 3, and that's it. So the factors of 6 are 1, 2, 3, and 6, either positive or negative. Any of these numbers, if I substitute them in here, could make that equation 0. Could all of them be? Sometimes, maybe not, but we need to check them. That's what we're going to be doing today. So here we go again, repeating the rational zeros theorem. The rational zeros theorem says if you are given a polynomial equation such as this one, you can make a fraction of the constant divided by the leading coefficient, we get a number. Once you find that number, all its factors, either plus or minus, one or some might be the zeros of the equation. And do we know what that means? Yes, that if we substitute them in there, it makes it 0. Copy that, and then I'm going to move on to, so we can do an example. I think it's better when we see it in action. Yes? Here we go. Example number 1. Copy this, including the instructions. It says, find the rational zeros of the polynomial function, then write the function as a product of factors. Example 1, find the rational zeros of polynomial function, then write the function as a product of factors. Function given, f of x equals x cubed plus 2x squared minus 19x minus 20. Copy that. I'll give you some time and then I'll go over it and then you'll follow along with copying the example. All right, so here we go. We're given this problem to rewrite as a product of factors for that equation, polynomial equation. And here's how it goes. Ready? I'm gonna leave the instructions there. Okay, here we go. First things first, step 1, pay attention to this part. Were we given a polynomial equation? Yes. So what is the first thing we do? We need to make a fraction. Okay, what is that fraction, Mr. Q? Well, it needs to have a constant on the numerator and a leading coefficient on the denominator. So according to this equation, what's my constant? My constant is negative 20. What is my leading coefficient? My leading coefficient is 1 because it's in standard form. There it is. So I come up with the number negative 20. Copy that. All right, that's step 1. Step 2, you take that number and find all its factors. What factors make 20? 1 times 20 2 times 10, 3 times nothing, 4 times 5, and 5 times 4, and then they repeat. So all these are factors of 20. So I'm going to write all of them in order. Here we go. I'm going to write 1, comma, 2, comma, 4, comma, 5, comma, 10, comma, 20. And all of these plus or minus could be a zero of the original polynomial function. Copy that. Okay. All right. Okay. So this next part, I want you to stay focused. Please pay attention because it's going to go pretty fast. Okay. So writing utensils down, look up to the screen. Ready? Here it goes. This next portion is, Mr. Q, how do we check to see which one of these is a zero of the equation? Let me show you. I'm going to start with positive 1, and I'm going to use synthetic division. You're like, oh, I see. So I'm going to put a 1 here. That's positive 1. And I'm going to divide this using synthetic division. So what's my coefficient? 1, 2, negative 19, and negative 20. The only thing right now, it's going to go a little bit faster because we already did the practice, didn't we? Yeah, so look up. I'm going to bring down the 1. Here it goes. 1 times 1 is 1. Combine, that's 3. 1 times 3 is 3. Combine, that's negative 16. 1 times negative 16 is negative 16. That's negative 36. Since this is not, the remainder is not 0, that means this could not be our 0. Copy that. Once again, this is not our 0 because our remainder was not 0. All right. So since positive 1 didn't work, I'm going to switch to red. What am I going to try next? I'm going to try negative 1. I'm going to write negative 1. Same coefficients, 1, 2, negative 19, negative 20. Here goes the process, bringing down the 1. What is negative 1 times 1? That's negative 1. Combined, that's 1. Negative 1 times 1 is negative 1. That's negative 20. Negative 1 times negative 20 is positive 20. What is the remainder? 0. Well, guess what? I'm going to write here, this is my 0. Copy that, please. You're like, man, Mr. Q, this is going pretty fast. Yeah, right? But we did all the practice, didn't we? Is our noodle ready for it? Of course, Mr. Q, we got this. All right. Next part is very important. So writing utensils down, look up to the screen. Look up, please, or you're going to miss it. So here we have 2 polynomials. Look up. My first one, which is a 0, and the remainder, which is our quotient. Look up. How do I write this now with variables? Well, this one is x plus 1. Does everybody know why this became x plus 1? Yes, because on our practice, when we did synthetic division, this, in order to get our divide and start synthetic division, we set it equal to 0 and solve, and that's what we got, yes? We're going backwards, okay? And what's the trinomial that we have left over here? Oh, we have x squared plus 1x minus 20. That is this. Copy that, please. So once again, the divisor of negative 1 became x plus 1 because we're going backwards. And the quotient is the remainder that we have, which is x squared plus 1x plus 20. Here it is. All right, are we done? Let's see. It says to write our function in factors. Okay, so we have factors, but can we factor this one a little bit more? Let's see. Negative 20, 1. Factors of negative 20 that add up to positive 1. For the sake of time, it's 5 times negative 4. What is 5 times negative 4? Negative 20. What is 5 plus negative 4? That's 1. So I'm going to rewrite this trinomial. x squared becomes x times x. One of the numbers is plus 5. The other one is minus 4. I bring down the divisor, which is x plus 1. And then we just write our function notation, which is equal to f of x. And we're done up to right there. There it is. And that's what you're going to do on tonight's home play. Okay? You're like, it's doable, Mr. Q. Good, good. Now, question, look up. Who noticed that we only did the factor of 1 and we started with plus minus? And the first one didn't work, but the second didn't. I mean, the first one didn't, the second did. What if none of them would have worked for the first number? What would we do then, Esmeralda?
You would do 2 then?
Yes, then we would move on to the next number, would be starting at positive 2. If that didn't work, then we go with negative 2. You're like, what? Does that mean I'm gonna have to go to, it's something that doesn't work, to maybe 4 and 5? Yes. Come on now, there's no shortcuts on this. It's like, imagine you're in PE or whatever, and they're like, okay guys, let's go run the mile. Oh, let me get my app out to run the mile. No, you gotta do the work, okay? All right, so here we go. Let's do another one together. Once again, the process was, first we write our fraction, find that number, find all factors of that number, and then start our synthetic division to find our 0. We write that as a divisor plus whatever was left, factor as much as we can, and write our equation. All right, here goes example 1Q. Copy this. You don't need the instructions anymore. Just write g of x equals x cubed plus 7x squared plus 16x plus 12. And we're going to do this one together. All right, first things first. What do? We write a fraction of the constant over the leading coefficient. So according to the equation, what's our constant? Our constant is positive 12. What's our leading coefficient? Since it's in standard form, it's the number 1. So what is 12 divided by 1? That is 12. All right, next we find all the factors of 12. 1 times 12, 2 times 6, 3 times 4, 4 times 3, and then they repeat. So I list all my factors in order from least to greatest. 1, 2, 3, 4, 6, and 12. All these could be possible zeros, either positive or negative. Now that we have all our factors listed, we're going to start. I'm going to use blue. I'm going to start with the first number 1, positive 1. I'm going to write that as my divisor. And what are my coefficients and constant? 1, 7, 16, 12. And let's do the process. Bring down the 1. 1 times 1 is 1. Combine, that's 8. 1 times 8 is 8. Combine, that's 24. 1 times 24 is 24. That's 36. Since this is not 0, this could not be our 0. Let's go to the next number. The next number is negative 1. Negative 1. So I write it here, negative 1. Same coefficients and constants. Here we go. Bring down the 1. Negative 1 times 1 is negative 1. Combine, that's 6. Negative 1 times 6, that's negative 6. Combine, that's 10. Negative 1 times 10 is negative 10. Combine, that's 2. Since this is not 0, this cannot be 0. We move on to the next one, which is positive 2. Positive 2. Same coefficients, 1, 7, 16, 12. Here go our process, bring down the 1. 2 times 1 is 2. Combine, that's 9. 2 times 9 is 18. Combine, that's 34. 2 times 34, that's 68. Combine, that's 80. Is this 0? No, that's not 0. Like, oh man, I know. Next, move on to 2 again, but now the negative. Negative 2. Same coefficients and constant. So bring down the 1. Negative 2 times 1, that's negative 2, combined that's 5. Negative 2 times 5, that's negative 10, combined that's 6. Negative 2 times 6, that's negative 12, combined that is 0. That means this is our 0. All right, so how do we write these polynomials? Well, the first one is x plus 2. Look at it, it was negative 2, so it has to be x plus 2. And what do we have left over here? A trinomial, x cubed, my bad, not x cubed, x squared, sorry. X squared plus 5x plus 6. Next, can we factor this trinomial? Let's find out. 6, 5. Factors of 6, that add up to 5. Oh, 2 times 3. What is 2 times 3? 6. What is 2 plus 3? 5. So let's factor this trinomial. This x squared becomes x times x, positive 2, positive 3. Bring down the divisor that we started with, which is x plus 2. And we write that as a function, which is g of x. And this is our equation. Woo, let's go. How are we doing? Good, Mr. Q. All right. So let's see. From 1 to 5, it's on your screen. How comfortable do you feel with this so far? 1 being the lowest, 5 being the highest. I got 5 fours, 5 fours, 5 fours, 5 fours, 5 fours, 1 3, 5 fours, 5 fours, 5 fours. Yes. Once again, if you did the practice with synthetic division, this should be a piece of cake by now, or at least you're getting there. So that means we need to do one by ourselves to make sure that we got it. Yes. All right.
HQ,
Yes.
just question. What LC? Where's LC in the equation? It's the first one, right? The biggest.
The leading coefficient. Yes.
Okay.
Good question. So look up, guys. They're asking where's the LC. The LC is the leading coefficient. Now, I don't know if you guys remember when we covered polynomials, and if I was to give you the polynomial 3x to the 5th plus 2x to the 4th plus x cubed plus 2x squared plus 5x plus 1. Look at it. Is it in standard form? Let's see, from the highest degree to the lowest degree, yes. So that means this is the leading term. That's my leading term. The coefficient is a number multiplying the variable. What number is multiplying the variable? The 3. This is our leading coefficient. Since this one doesn't have a number there, then it's an invisible 1. Yes. Okay. All right. So with that said, example 1 supercube. Copy this. H of x equals x cubed plus 5x squared minus 17x minus 21. I'll give you guys some time. Do that one by yourself. Ready and go. All right. I gave you guys a head start. So let's see. First thing you did, you wrote a fraction. What was that fraction? Negative 21 over the leading coefficient, which was 1. And what is that number you came up with negative 21? Step 2, write all factors of that number. 1 times 21, 3 times 7, and that's it. From there, list all factors. 1, 3, 7, 21. And they could be either positive or negative. From there, we start our synthetic division. My first number that I start with is 1, and I'm going to start with positive 1. So positive 1. My coefficients here are 1, 5, negative 17, and the constant negative 21. I do my synthetic division, bring down the 1. 1 times 1 is 1. Goes there, combine that 6. 1 times 6 is 6. Combine that's negative 11. 1 times negative 11, negative 11. So that's negative 32. Since this is not 0, that is not our 0. Next one is negative 1. Negative 1, same coefficients, 1, 5, negative 17, negative 21. Synthetic division, bring down the 1. Negative 1 times 1, that's negative 1. Combine, that's 4. Negative 1 times 4, that's negative 4. Combine, that's negative 21. Negative 1 times negative 21 is positive 21. So negative 21, positive 21, that is 0. So that means this is our 0. How do we write that with our variable now? X plus 3. What's left over? X squared plus 4x minus 21. can we factor this a little bit more? Let's find out. Negative 21 and positive 4. Factors of negative 21 that add to positive 4, that's 7 and negative 3. 7 times negative 3, negative 21. 7 plus negative 3 is 4. So let's factor this a little bit more. X squared is x times x. The first number is plus 7. The other number is minus 3. Bring down the divisor, x plus 3. And we write it in function notation, h of x. And we are done. Ooh, let's go. All right. So
Mr. Q, where'd you get the 3 from?
what 3?
In x plus 3.
X, right. Oh, my bad. It's x plus 1. I'm sorry. I did that on purpose. See if you were paying attention. Thank you. Sorry. X plus 1. Plus 1. My bad. There it is. You see, you guys caught it. I did that on purpose. Pretty good, right? All right. So now that we have that, let's see, I'm going to relaunch this one more time. How comfortable do you feel now that you did one by yourself from 1 to 5? 5, 5, 5s, 4 5s, 4 5, 4 5s, 4 5, 4 5, 4 5s, 4 5s, 4 5s, 1, 3. All right. So you just need some independent practice. So once again, guys, you need to do your practice, guys, because we're going to add more steps to this on the following session. So make sure you do your practice. Once again, reminder, tutoring is going to be at 2 o'clock. So if you want to join us, join us. And also those of you that are going to your face-to-face class this afternoon, make sure you go expeditiously to your classroom. Remember, they're not going to let people roam around. And it's going to be our session for today, guys. I hope, we're getting closer to where we need to be. But this is exactly what I need from you just for today. Also, don't, what was going to say? Oh yeah, you're going to have some challenging problems in the home plate tonight. That might be a little bit more stretched than this. That's fine. Just use the process and follow the process. Trust, and use the force. All right, guys? That'll be our session for today. Have a good one, guys. I'll see you guys next time. Peace. Bye.
Thank you, Mr. Q. Have a good day. Hey, Mr. Q.